morning, students. In this lecture, I am going to solve problems on Fourier cosine transform. Write down, students. Find Fourier cosine transform of f of x that is equal to 1 by 1 plus x square. Hence, derive Fourier sine transform of phi of x that is equal to x by 1 plus x square. X by 1 plus x square. Solution, students. Given f of x is equal to what, students? 1 by 1 plus x square. 1 by 1 plus x square. Now, Fourier cosine transform, students. Fourier cosine transform of f of x is Fourier cosine transform is denoted by, students, fc of s, students. fc of s. So that is equal to integral 0 to infinity f of x cos sx dx. Cos sx dx. So that is equal to integral 0 to infinity f of x, students, 1 by 1 plus x square into cos sx dx. Cos sx dx. This is fc, students. Say this is 1. This is 1. See, students, here also we like 1 by 1 plus x square. In such cases, students, exactly, differentiate with respect to s, students. Differentiate with respect to s. So differentiate 1 with respect to s, we get dfc by ds, that is equal to integral 0 to infinity 1 by 1 plus x square, because we are differentiating with respect to s, students, because we have here s term. So already told you, students, whenever there is a differentiate with respect to s, whenever we take inside of the integration, it will becomes dou by dou s, or, students, dou by dou s into cos sx dx. Cos sx dx, that is equal to integral 0 to infinity 1 by 1 plus x square derivative, students, minus sin sx into sin sx into again derivative of sx with respect to s, students, we get x into dx that is equal to minus integral 0 to infinity, here we have x, students, x divided by 1 plus x square into sin sx dx. Now, say, students, I want, here we have x square, students. So numerator also I want to x square. So multiply with x by x, students. So x by x. Now, see, students, plus 1. So I want to add and subtract 1, students. Add and subtract 1. Now I want to separate the term, students. X square plus 1 as one term and minus 1 as another term. So that is equal to, multiply with minus, students. So minus integral 0 to infinity x square plus 1 by x into x square plus 1 into, students, sin sx dx. Minus into minus, students, plus. Minus into minus, plus. So integral 0 to infinity 1 by x into 1 plus x square sin sx dx. So that is equal to x square plus 1 cancel, students. We get here minus integral 0 to infinity sin sx by x into dx plus integral 0 to infinity 1 by x into 1 plus x square sin sx dx. Now, say, students, I have a formula, students. I have a formula. What is formula, students? Integral 0 to infinity sin sx by x dx value pi by 2, students. What, students? Pi by 2. So dfc by ds, that is equal to dfc by ds, that is equal to, this value is pi by 2, students. So we get minus pi by 2 plus the value, students, same, students, integral 0 to infinity 1 by x 1 plus x square sin sx dx. Now you differentiate this one, students. Differentiate above with respect to s, students. S, we get so we get here, students, d square fc by ds square, that is equal to constant, student. Constant, differentiate of constant is 0. So 0 plus integral 0 to infinity 1 by x into 1 plus x square. See, students, derivative of sin sx is cos sx into x dx. So x cancel here. So d square fc by ds square, that is equal to, see, students, this one, integral 0 to infinity 1 by 1 plus x square, 1 by 1 plus x square, cos sx dx. So this value is, students, fc. This value is fc. So that implies d square fc by ds square. Now you transpose to the left hand side, students. So minus fc, that is equal to 0. Now this is a linear differential equation, students. Linear differential equation. What is complete solution here, students? Right hand side, no function, students. So complementary function. What, students? Complementary function. So symbolic form. What is symbolic form, students? D square minus 1 into fc, that is equal to 0. Now you write auxiliary equation, students. Auxiliary equation. So what is auxiliary equation? D square minus 1 is equal to 0. That implies d is equal to plus or minus 1, students. Plus or minus 1. So complete solution, students. Here complete solution is a complementary function. So complete solution fc, that is equal to c1 e power. See, students, independent variable is s, students. So minus s plus c2 e power plus s. Now I want to find fc value, students. C1 c2 value, students. I want to find c1 c2 values. Okay, for that I want to differentiate fc, students. So dfc by ds, students, we get here minus c1 e power minus s plus e power s derivative is e power s. So c2 e power s, students, plus s. All I do says this is 1, students, 1, and say this is this one, students. I think so. dfc by ds. Say this is 2, students, 2. And this is 3, and this is 4, students, 4. Let us continue, students. Say this is 1, students. fc of 1 by integral 0 to infinity 1 by 1 plus x square cos sx dx is equal to 1, and dfc by ds value is 2, students. Say fc of this is our solution, students, fc, and we are differentiating, students. Say this is 3 and 4, students. Now I want to find here c1 c2 values, students. C1 c2 values. For that, put s is equal to 0, students. S is equal to 0. In 1 and 3, students. 1 and 3 we get. See, students, fc of s, students. fc of 0. That is equal to e power 0 and e power 0, students. 1. So c1 plus c2. Okay, now FC of 0 students, so cos 0 value is 1, so we get here C1 plus C2, that is equal to integral 0 to infinity cos 0 value is 1 students, so 1 by 1 plus x square dx, that is equal students, it is tan inverse x between 0 to infinity, because 1 by 1 plus x square integration is tan inverse x students. So substitute upper limit students, tan inverse infinity minus lower limit tan inverse 0. So tan inverse infinity students, pi by 2, tan inverse 0 is 0. So C1 plus C2 value is pi by 2 students. So this is 5. This is 5. Now again put S is equal to 0 in 2 and 4 students. 2 and 4 we get 2 and 4 students. So DFC of S students, S value is 0. 0 divided by ds, that is equal to, here also e power 0 value 1 students, so we get minus c plus c2, minus c1 plus c2. So c students here, s value is 0, so s value is 0 here students, so we get this term value 0, so we get here minus pi by 2 students, minus pi by 2, this value is minus pi by 2, that means minus c1 plus c2 is equal to minus pi by 2. So this is 6 students, 6. Say 5 plus 6 students, 5 plus 6, that implies c1 cancel students, so it is 2c2, that is equal to value 0 students, c2 value is 0. When c2 value is 0 here, substitute here, we get c1 is equal to students pi by 2, c1 is equal to pi by 2 students. So substitute in 3 students, substitute in 3, we get FC of S, that is equal to pi by 2 e power minus s students, pi by 2 e power minus s. This is the Fourier cosine transform of 1 by 1 plus x square students. For this project students, we differentiate 1 and twice. Okay, so thereby we get a differential equation, we find complete solution. Okay, and thereby you find C1, C2 value students, like in this way. Okay students, now see students, what he mentioned, for hence derive, that means using this result, find the Fourier sine transform of phi of x, that is equal to x by 1 plus x square students. Now see students, Fourier sine transform, Fourier sine transform, what is Fourier sine transform students? Fs of s students, that is equal to integral 0 to infinity f of x students, f of x sin sx dx, that is equal to integral 0 to infinity f of x is x by 1 plus x square sin sx dx. Now see students, he says that hence derive on, that means we are using this result students. Say see students, x by 1 plus x square into sin sx dx students. Simple students, you differentiate this fc, so d by ds of fc students, we get here students, come on tell me, integral 0 to infinity 1 by 1 plus x square, what is derivative of cos x students? Minus sine sx into x students, into dx students, into dx. So see students here, x by 1 plus x square sin sx dx, what is extra term here students? Minus. So this value is students, that is equal to minus d by ds of fc, that is equal minus d by ds of fc, means pi by 2 e power minus s students, so that is equal to minus pi by 2 derivative of e power minus s students, e power minus s into minus 1, so that is equal to pi by 2 e power minus s, pi by 2 e power minus s. This is the Fourier sine transform of given function, students. Given function. Hope you understand, students. Thank you for watching this video. Jai Hind.